In this class, we'll continue our discussion of ANOVA and how we use it to evaluate hypotheses concerning mean differences. The results of an ANOVA are presented in what's called a summary table, which you see represented here in this slide. In the rows of the table are the three types of variance we analyze in analysis of variance. Treatment variance, which refers to how the means of groups deviate from the grand mean. Error variance, which refers to how individual scores deviate from the mean of their group. And total variance, which refers to how all participant scores deviate from the grand mean. In the columns in the computation is the computation of the sample variance broken down into its parts. First we have the degrees of freedom for treatment, then error and total variance. We will remember that degrees of freedom is the denominator of a sample variance. Second, we have the sums of squares for treatment, error, and total, which we will recall is the numerator of a variance. Third, we have the mean squares, or the mean of the sums of the squares, which is just another name for the sums of squares divided by degrees of freedom, or the variance for treatment and error. Note that the total variance is not reported in a summary table. Finally, we have the F statistic and a column called significance, which reports the probability associated with the test statistic. Let's learn more about analysis of variance, a one-way analysis of variance, by looking at how numbers are computed in each section of the summary table. First of all, for degrees of freedom. Degrees of freedom treatment is equal to k minus 1, or the number of levels of the independent variable minus 1. We have already been introduced to this degree of freedom as the degree of freedom numerator in the F table. Degrees of freedom error is the number of participants in each group minus 1 times the number of groups. We've already been introduced to this type of degree of freedom as the degree of freedom denominator in the F table. Notice how we are identifying the numerator as carrying information about the treatment effect and that the denominator is carrying information about error. Degrees of freedom total is equal to the number of participants minus 1, or n minus 1. An important principle to note here is that degrees of freedom treatment plus degrees of freedom error equal degrees of freedom total. Continuing our look at the summary table, we turn our attention to the sums of squares. Sums of squares for the treatment concern how each group mean deviates from the grand mean. For example, we would multiply the number of participants in a single group, here noted with the symbol of small n, times the sum of squares of the mean of the experimental group minus the grand mean, or 10 minus 15 squared, and the square of the mean of the standard group minus the grand mean, which is 14 minus 15 squared, and the square of the mean of the no treatment group minus the grand mean, which is 21 minus 15 squared. Sums of squares error is the sum of the square of each individual Beck depression inventory score in the experimental group minus the mean of that group minus 10 plus the plus the sum of the square of each individual score in the standard treatment group minus the mean of that group, or 14, plus the sum of the square of each individual score in the no treatment group minus the mean of that group, or 21. Finally, sums of squares total is the sum of the squares of each participant's score minus the grand mean, or 15. An important principle here is that sums of squares treatment plus sums of squares error equals sums of squares total. This is to say that in analysis of variance, we partition or segment total variance into two parts: a part that carries information about the effect of treatment, or sums of squares treatment, and a part that carries information about sampling error, or sums of squares. Let's finish our review of this analysis of variance in the summary table by first looking at the mean squares. The mean squares for the treatment effect is derived by dividing the sums of squares for treatment by the degrees of freedom for treatment. Thus we say we have computed the variance for treatment, or the mean of the sums of squares. Similarly, MS error, mean squares error, is derived by dividing the sums of squares for error by the degrees of freedom for error. Thus we say we have computed the variance associated with the error. The F statistic, or F ratio, is nothing more than mean square treatment divided by mean square error, or the variance for treatment divided by the variance for error. Consistent with our discussion of the t-test, the numerator tells us about the effect of the treatment, and the denominator is an estimate of sampling error. Finally, the significance column will report the probability associated with the test statistic and help us determine if we will accept or reject the null hypothesis.